Hey math people, it is Gina, the nerdy math girl, and I'm gonna help you math analysis kids with some of the trig equations that you have coming up. Hopefully you watched my inverse trig functions video, and now here we go. So when the question says the sine of x is a half, you gotta think on your unit circle, where exactly is the sine of half? Now when we did inverse trig functions, remember I said that it had to be on this side of the unit circle, it had to be between negative pi over 2 and pi over 2. Well, when the question looks like this, okay, you're gonna get two different places. So the sine is x, the sine of x is a half in two spots, right here, because remember the sine is a vertical distance and it's only a half, and it's short, and also right here. So the sine of x is a half at this spot, which is pi over 6, and at this spot, which is 1, 2, 3, 4, 5 pi over 6. Now there's a couple of different things that you might have to do. This right here says that we want our answers to be between 0 and 2 pi. And so my answer to this question truly is pi over 6 and 5 pi over 6. Okay, that's the answer. Now, had the domain, instead of this, had it said find all solutions, okay, if it says to find all solutions, first of all, okay, I'm not very smart, and so here's how I make myself remember it. I think of all as ALK, A-L-K, ALK solutions, because if it says all solutions, then that helps me remember that I'm gonna have a K in my answer. K represents an integer, and so you would get pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. If it says all solutions, this is your answer. If it says from 0 to 2 pi, your answer is just pi over 6 and 5 pi over 6. Okay, what the heck does this mean? It means you go to pi over 6 and you can go around 2 pi, or 2 pi twice, or 2 pi 3 times, or 2 pi 4 pi times, right? K represents an integer, not a fraction. So this would be the solution if it's all solutions, all solutions. And if it's just between 0 and 2 pi, then there's your answer, okay? If the question says the angle whose cosine, or if the cosine is 2x, so this is a totally new problem. If this number is anything other than just x or theta, okay, so if it's 2 theta, or if it's 3 theta, or if it's theta over 2, anything other than 2 theta, I just box it off for a minute. And then I answer the question, where is the cosine 1/2? So cosine is a half that's over short, so it's here at pi over 3 and here at 5 pi over 3. Right? So at pi over 3 and at 5 pi over 3, now here guys, whether it says from 0 to 2 pi or all solutions, either way you have to add the 2 pi k. So stay with me. You add the 2 pi k because you're trying to find x, not 2x. So 2x equals this. So I'm going to say 2x equals that and 2x equals this. You good so far? So now to find x, you have to divide by 2. So if I divided this by 2, if I divided by 2, dividing by 2 is like multiplying by a half, right? So half of pi over 3 is pi over 6. Half of 2 pi k over 2, like if you have 2 pi k over 2, right? Or half of that is just plus pi k. You do the same thing right here. If I divided this by 2, divided that by 2, 5 pi over 3, half of that is 5 pi over 6, plus 2 pi k over 2 is going to give you pi k. So if the question said find all solutions, this would be your answer. If it says find all solutions. But if it says find all your solutions between 0 and 2 pi, like it says here, okay, you have to put in numbers for k. So look, if I put in 0 for k, then I get pi over 6 plus 0 pi, right? Pi over 6. If I put in 1 for k, because k represents integers, if I put in 1, I get pi over 6 plus pi. Okay, so if you get a common denominator, pi, isn't pi the same thing as multiplied by 6 over 6? So that's pi over 6 plus 6 pi over 6. That would give you 7 pi over 6, right, from this part right here. So I put in 0, I put in 1, and now I'm going to put in 2. So if I put in 2, well, that's 2 pi plus pi over 6. That's too far around the circle. That's 2 pi plus pi over 6, which if you really felt like figuring it out, it's 13 pi over 6. But 13 pi over 6 is not in my domain from 0 to 2 pi. So I don't have to put in the 2. Okay, because I'm done. I'm done putting in numbers there. But now I have to go on to this one. If I put in a 0 here, I get 5 pi over 6 plus 0 gives me 5 pi over 6. Then if I put in the 1, 5 pi over 6 plus pi, and remember getting a common denominator, that's 6 pi over 6. So 5 pi over 6 plus 6 pi over 6 would give me 11 pi over 6. If I decided to put in the 2, I can die. Why not try? But that's 2 pi right there. 2 pi alone is already around the circle. If I add 5 pi over 6, I'm really going around the circle, so I don't have to put in anything else. Here's the bottom line, guys. If you have a 2 over here, you think that you're going to put in 2 different numbers, a 0 and a 1. If this were a 3, I think I'm going to put in 3 different numbers, a 0, a 1, and a 2. Okay, so sometimes it's going to be like 3 pi or 3 theta over 2, and you're going to put 2 numbers into one of them and 1 in the other. Just look and see if it goes around the circle too many times or not. Okay, so understand that if the question said find all solutions, this is your answer with the k's. But if the question says find your solutions between 0 and 2 pi, here you go. Not bad. Okay, so let's check out number 3. Number 3, you have a cosine squared and then just a cosine. You get to factor. Do you like factoring? Maybe. I have some videos on factoring if you need help with factoring, so you go and look at those. But let's just pretend for a minute that this was 2m squared plus m minus 1. Just for kicks. Okay, so now we're gonna factor that. And if you do, any way you factor it, some of you use the slide method, some of you use trial and error, whatever. So plus, minus, okay, so you see if I multiply this out, 2m squared plus 2m minus 1m gives me 1m and then minus 1. So this tells me that m equals, if I set that equal to 0, m is 1/2 and m is negative 1. Awesome, but m isn't really part of our question. So what we were putting in, instead of cosine theta, we were just putting in m. So really, when you do this, that's saying that the cosine of theta is 1/2 or the cosine of theta is negative 1. Okay, so if you can go straight from here to factoring this, that would be 2 cosine theta minus 1 and cosine theta plus 1. You can do it that way. Or you can just put in some dummy variable like m and solve it that way. Okay, so we're not done. So cosine is 1/2. Cosine is 1/2. It's short in those 2 spots. Right? So this is 1 pi over 6, 2 pi over 6, which is pi over 3. And then in this spot, that's 5 pi over 3. Cosine is negative 1 right here. Yeah? And that's at pi. So if the question is between 0 and 2 pi, these are your answers. If the question said find all solutions, then you'd have pi over 3 plus 2 pi k. Pi plus 2 pi k, 5 pi over 3 plus 2 pi k. You wouldn't really have to put in the 0, 1, and 2. You could start like that if you wanted to, but if you were going between 0 and 2 pi, and if this were just a regular theta, not a 2 theta or 3 theta, then honestly you're only going to be able to put in the 0 anyway, and so you shouldn't have to even start with that. If you don't know what I just said, it's okay. Just ignore it. Okay, look at the last one. This last one is the hard one. Okay, stay with me. And so you go to factor this. So remember, when you factor, you have to get everything on one side. Okay, set it equal to 0 over here. So I'm just going to factor it just like this. And you can use the m's if you want. Multiply to give you 6, subtract to give you 1 are going to be 3 and 2. I want a minus 3 and a plus 2. Right, so if I multiply that out, if I FOIL it, I'm going to get back to here. And so now tangent theta equals 3 or tangent theta equals negative 2. Which is awesome, but I don't have that memorized because it's not on my unit circle. So I need my calculator. And we're gonna talk first in terms of degrees. Right here it says to do it between 0 and 2 pi, which means radians. We're gonna talk about radians, but we're gonna talk about degrees so you can understand that better. Okay, so I'm gonna make sure my calculator is in degrees, and I'm gonna hit inverse tangent 3. And my calculator tells me that this is 72 degrees. Okay, you're staying with me, right? There's 2 places where the tangent would be 3, right? At 72 degrees, right up here somewhere, but tangent is also positive, could be positive 3 down here. Okay, you have to find 2 places. When it was on the unit circle, we could just tell where it was. But if you were doing this on the calculator, your calculator would have only given you 60 degrees and you would have had to figure out this one. So the question that you always have to ask yourself when it comes down to this part, you have to say, where else is the, and this will be your trig function, and this will be positive or negative. Okay, so here, I would go into here and I'd say, where else is the tangent? See how that's positive? Where else is the tangent positive? And I think, hey, it's down here in this quadrant. So you compare everything right here. If this is 72 degrees this way, then you've got to go 72 degrees that way. So that would have been 180 degrees, and you add 72 because you're going toward the 270. So you say 180 plus 72 gives you 252. There's a cat right underneath me, and she's trying to say hello. Okay, I'm gonna ignore her. Maybe you can too. Okay, so this is 72 degrees and 252. All right, if we were doing inverse tangent negative 2, so inverse tangent of negative 2, then my calculator gives me negative 63 degrees, which quite honestly isn't even between 0 and 360. Right, so let's think what this is. Negative 63 is right here, and I have to ask myself that question. Where else is the tangent negative? Okay, tangent is also negative up here, and so if this is 63 this way, I've got to go 63 that way. So this angle right here is 180 going toward 90. So it's 180 minus 63, right? Which is 117. And then this one, can you see, you can't call it negative 63. If it says between 0 and 360, you've got to call it this way, 360 minus 63. 360 minus 63 would be, I think, 297 maybe? No. Yeah, 297. Okay, so in degrees, these are the 4 answers. I say that because I want you to understand what is happening with degrees. I think it's easy for you to see what's going on with degrees. But now, hang on, let me get something. Okay, so I'm going to get rid of this so you can see up here. Here's the next thing I need you to understand. On the unit circle, okay, this is 0. This right here is pi, which is 3.14. We're going to call it about 3, right? That's cool. So halfway around, this is 1.5. 3, this is about 4.5. And this is about 6. It's 6.28, 2 pi, but you know, just so we have a clue what's going on. Okay, so now, when we do the same problem, we're going to do this in radians. So we're going to put our calculator in radians. And we're going to hit inverse tangent 3, inverse tangent 3. And my calculator is giving me 1 point, let's just say 2. Okay, so I want you to understand where 1.2 is. This is 1.5. So 1.2 is somewhere right here. It's actually at 72 degrees. Okay, that's where it is if it's in degrees, but in radians it's called 1.2. So then you have to say to yourself, where else is the tangent positive? So tangent is also positive in this quadrant. And so you say, if this is 1.2, I compare everything to here, I got to go 1.2 this way. So now this, to this direction, that's pi. It's pi plus 1.2, right? So 1.2 plus pi is going to give you 4 It's about 4.4. Okay, and 4.4 makes sense because it's somewhere between 3 and 4.5. Okay, so then you come down here, and in radians, you hit inverse tangent -2. Inverse tangent -2. And I get -1.1. Which is going to be right down here somewhere, right? This would be -1.5. It's actually -63 degrees, right? If we were in degrees, but we're not. So this is -1.1. And so that's where this is. And I'm going to say, where else is the tangent negative? Well, tangent is also negative up here compared to this line right here. So I'm going to go up this way. If this is 1.1 this way, this is 1.1 this way. I'm going to take pi, and I'm going toward pi over 2, right? So pi minus 1.1. So pi minus 1.1 is about around 2.0. Yeah, I can't even call this -1.1. Why? Because it said that I was supposed to go between 0 and 2 pi. And so if I want to call this, you know, within that range, I have to call it's 2 pi minus 1.1. This is 2 pi minus 1.1. 2, can see nothing without these glasses. 2 pi minus 1.1 is going to give you about 5.2, which makes sense. It's somewhere between 4.5 and 6 o'clock, and 6 radians. So 5.2, 2.0, and these two would be your solutions for this problem. You got to go through this a few times, guys, yourself, because the way this works, it's different if you have sine and cosine. So if the sine was positive, okay, if you came down here and you said, where else is the sine a positive number? The calculator is going to give you this quadrant. In the first quadrant, you're going to have to say, I got to go over here, right? So you'd have to say pi minus whatever you had gotten in the first quadrant. If the sign was negative, it's going to be down here, right? So you'd be taking this number and then the one here. If we're talking cosine, cosine's totally different. So cosine is going to be over here on the side in the first and the fourth quadrant. And so your calculator would give you something in this quadrant if it was positive. And then where else is cosine positive is here. So you'd be having to do 2 pi minus, right, to get here. Yeah, think about, compare everything to right here. If the cosine was negative, your calculator is going to give you this quadrant. So you really got to think through that. If your calculator gives you this quadrant, your arrow is going to be going like that. And so when you say where else is the cosine negative, it's going to be in this quadrant, right? And so you got to take your arrow from here because it's got to be just as long of an arrow as this way, but it's got to land over here. So this one will be your first angle, and the second one would be 2 pi minus, right? I hope that gets it. You're going to have to go through a few of these by yourself, but you've got it, and I will do some more trig equations with you next time. See ya!